Check, check. Audio test for Twitch. Audio test for YouTube. Okay, my microphone is turned on. My webcam is frozen. Let me take a look at that. Yep, that's exactly what y'all are seeing. Bye-bye. Hello. Ooh. Is that unfrozen? That's unfrozen. Okay. Audio, check. Video, check. Guess now I should entertain the masses and get my work done. Okie dokie. Blank slate. Let's try to not make a mess. Okay. We'll start here. What day is it? 20? Okay. So it's story time. Here's hoping I can actually pull this off of YouTube as a video. Otherwise, it's going to be kind of pointless for me to talk to nobody live. So let's review the features I want to implement and compare that with the amount of time I have, at least during the jam, and try to figure out exactly what I want as the final results. All right, so this was my checklist at the end of Linux Game Jam. So a couple of these are pretty high level features, but I think they're good targets for the end of the jam. Oh, something else I should pull up would be my schedule. I'm a bureaucrat. It's all got to go on a spreadsheet. So I have planning and streaming today. This didn't work out exactly how I wanted. This actually became, let's see here. I was out at Radio Club pretty much the whole time. This is going well. So that's working out. Next up, the first sprint will be the work week. I will have 3 streams and my regular 5 days of work and 2 classes. Can probably come up with ideas during then, write my own notes, but I probably won't be able to get too deep into development. Just looking at a stream rate thing. My bit rate's low. Story of my life. Okay. So it's about maybe 6 or 10 hours of work I'll be able to put in between those three. Same for this part. Although maybe actually a little more, closer to 12 between those 4 sessions. Maybe even 15 if I sneak some more in, but that's too high of an estimate. I need to leave some slack in the schedule. So call it like maybe 6-ish. Yeah. Sprint 1 is the normal work week. Let me put this. Sprint 2, weekend number 2. That's going to be, is that 10? A little better. And sprint 3, which I'll have kind of like a middle one here. The short week I'm not going to really plan any goals for. I'll use it to check my progress after those 2 sprints or events, and have like a and there will be 1 stream. Should put how many streams I'm going to do too. And this is like now. Stream number 1. Sprint number 3 is the big finish, and that is like at least the size of the first 2 combined, but potentially as much as double. So that would be really good. So if nothing really starts getting done until the 30th, that kind of makes sense. So that's my resources. Now let's have a look at what I can spend it on. Maybe demo a little bit and make sure I'm working on the right things here. So I should be able to go into my directory. Okay. Here's the demo. One thing that doesn't look great is hit register, I get a REPL, and I need to import the test scene. Unexpected indent. What did I press? Super weird. Okay, so I should be able to see, because I can never remember the name of it. Key test? Key registration. That's the function I need to call. And when I call that, it registers a bunch of key codes, and I can exit the REPL by pressing Control D. When I come back to this guy, now it's ready to accept key input. A lot of hacks there. I'm gonna try to list out everything I just had to unhack. So let me just say, like, what was this, double header. So number one priority will be so those hacks would be key registration. It has to take place. Here's the reason for that that whole thing with the REPL is it has to register keys after the C++ engine loads the target scene. You can register key presses in Python, but only on the current scene. But all the Python classes get loaded at the time the program starts, and the current scene at that time is the main menu screen. So you can't register keys to take place on the example game scene until it's loaded. So I could make this button call key registration directly, but I also needed a REPL for other testing, so I just used the button to do both. So what I really need is some sort of callback when a scene loads. Run startup code. And really what I was hoping for is that associate a scene like this is a this scene would be a view of the game's UI. Maybe you need like a different scene, like a mini game or something. That's great. But everything that looks like this should use the same scene. And like it has UI elements on it, like as you pick up the key cards, you get these things showing in your inventory here. Very simplified, hacky demo. You can use the keys as well, and it currently just says in the terminal what actions are occurring with your inventory, but that could easily, with a little bit of more Python code, show on screen when something occurs. But what I really want is for this scene to be associated with the test scene class. And I'd also like a scene for the main menu to run the Python style one and not the C++ only style one. That would allow me to write scripts that run against the main menu, either create new options, load different scenes without actually recompiling, which is kind of the whole point of this scripting thing entirely. Secondly, what else did I have to do here? That really is, main and the worst bugs. The main bug that I see right here is that key release is counting as the same kind of event as key press. Python can register a key, but it can't register for a purpose. I guess I'll pull up some code shortly to have a look at that, but right now let's keep planning. right? What crashed? I think some of those live clients crashed, but since I'm streaming through OBS, I am presumably still live. Let's investigate that. My poor computer. Like, why is my title bar not hidden now? There we go. So, and this is really the category of stuff that is new features. I got one more bug to report. Nope. I had a audio bug missing library in my standalone zipped version, so I would like to make that actually work. Need to test it against a brand new fresh virtual machine. Okay, so now let's look at the new stuff. This is a lot of ideation I did last week. Okay, so what does... My goodness, that's a lot of buttons, isn't it? Here. What does move between grids mean? So if I go over here... By the way, I have collision with entities. It should show up in the... Way too much stuff open, right? Yeah. I'm being blocked by other entities. And being blocked by the edge of the map. I don't think the same message shows up when I'm blocked by. Hell of an animation glitch too, isn't it? Does mean I can kind of really glitch out. Great. So moving between boards would be anytime that I get to the edge here. I guess that's not really the edge. It looks like there's an extra void tile right there. I would want to be able to press up against the edge, cause some kind of event, and load a different grid here. And that's obviously useful for about a billion reasons, such as just loading a different town, loading the wilderness, or whatever. So, yeah, that's way up there. Never had the player die. And I would also really like to have Python libraries that produce plots show on screen. And in game terms, that could be used for stuff like procedural generation. For my purposes, I actually want to be able to show like level curves, your wealth over time, other kinds of like stats about your character's performance or what different stuff does. But that's kind of one specific thing, is just interacting with probably the Python image library class to get that to play well with the sprites buffers from simple fast media layer. But it is a good one. Entity templates, we'll come back to this because the ECS is going to be the big one, probably a whole separate priority. All right, so let's take some notes. I also want to talk about another annoying hack that's presently in the thing. Let's see if I can. There we go. Got to kind of slip around corners with this double movement bug in. So let's say I want to zoom in and out. That's the mouse wheel. And let's say I want to drag the camera around. So right now the camera is moving. You can see the grayed out area is places I can't see. And the bright area is places the player has field of vision to. So I can move around and watch what happens when I move. The recenter button appears. So I can move around. We're in this free camera mode that if I move around, the camera stays wherever I left it and it doesn't follow the player. When I hit recenter, it instantly snaps to the player, but the recenter button does not disappear. And then if I move now, the recenter button has disappeared. So there is something that occurs on a mouse event which sets the camera following mode, but the UI to express that, like right now it says free. If I hit recenter, it's recentered, but it says free in the top right corner. If I move, it says following. So that's the camera mode. Following mode works. Free mode works. But the Python-based UI doesn't have accurate information about the camera mode until there is a keyboard event. And that's definitely wrong. So camera mode. And I don't even know exactly what's causing this weird interaction between keyboard and mouse, but camera follows correctly, which is, you know. And I'll say something else is like, it's actually animated. Like if we look at this guy, he's not snapping for block to block. I mean, he is a little bit on the second motion that's not really supposed to happen. But as he moves from tile to tile, he's animated crossing all the pixels of that block and smoothly going across the grid square. And the camera is following that smooth position. So that's exactly what I want, and was kind of tricky behavior to get working. We need to make sure that that good camera behavior stays put while I'm fixing the bugs around it. Because really what I would like is for the camera to have all these same features, but the buttons appear at the right time. And it's just something about there's no events related to there's no events related to camera mode changing. Also, I think too much of that is being handled by C++ and exposed as a quick little hack for Python to know about it at all. This could probably get fixed when I go about implementing some of these other classes and features, which I'm trying to work through here. Okay, so which components and systems do I need? And this might be a good time to break out the code. Let me take a look at the code editor. Where's the code editor? I only got about a dozen windows open. Let's take, that's my waiting room. Here's the code. Okay, so let's pull this on over. Actually, let me tidy up just a smidge. Pull my stream statuses over. Okay. So here's the code. And what I want to look at is, I mean, basically all of this. How the C++ side of McRogueface works. So a lot of it takes place in entity. The C++ side is not really not a lot going on in this data container. Entity is a very lightweight container in a entity component system. So a lot of the heavy work is being done by the grid component. And under the rules I was discussing, cgrid, the grid component, is the relationship between an entity like the player, like one of these doors, like any of these NPC guys laying around. I don't have tiles as entities because I really wanted to have like many tens of thousands of tiles as a potential feature. So that's just integers on an array, which represents the grid, whether you can see through a spot, whether you're blocked by a spot. So they don't really have a lot of there's no components on tiles, which I hope will not be a huge pain later to implement weird stuff. Maybe just put an entity where you have a weird thing and have it interact with the grid to respond to those components. So a weird door or a pseudo-wudo would be an entity, even though it acts somewhat like a tile. Now I gotta think through more of that too, I think. But the relationship between an entity and a grid, this player entity is on this grid, which has all these walkable, discovered, undiscovered, visible, non-visible tiles from the player's perspective. So what does the grid class do? And that should be in components.h. And really all it is a container for data. So what does it have? Is this entity visible? What's its XY coordinate on the grid? What does it look like in graphical terms? Which grid it's on? It has to be initialized with all those values. And it has a really basic default constructor, which you see we got visible as the member data. That's being assigned to in this, I don't know the term for it in C++, the just really abbreviated constructor. The constructor is empty code, and all it does is run this stuff on the other classes. So a lot of the work is being done by the grid class, which isn't a type of entity, it's a whole other thing, and index sprite, which is basically just saying I have a tile sheet or something, It's 100 by 100 sprites or 64 by 64, and we can just take one number and say I am tile number X on this tile sheet, and that's where you can go find my visible graphics. So let's go have a look at the grid. And grid has this kind of internal class I use. Does nothing but contain data. It's the layers of the grid. So we have a color, which is a solid color. I use that when I want to, like I can make a grid look like a entire gradient of color, or have like slightly random changes to the color, but there's no graphics at all. It's a solid color on that block. Walkable means entities can go over top of it. That's a yes or no Boolean. Tile sprite, if you want the ground to be have sprites, or another thing you can use that for is you can put a color of like brown or green, and then put a tile sprite with transparency that has like a couple of leaves of grass or a couple of rocks. So that's the graphics on top of the ground. Transparent is another Boolean. You can use this to make like a block of glass would be transparent yes, walkable no. It allows the field of view to go through it, but not for things to walk through it. Visible, this is whether or not the player entity can see it. I might have a bit of an issue of, like, if I really want to simulate the field of view of other entities on the grid, they can't all use the same visible field on the grid, or they won't be able to see different things. This is like the whole map says whether or not the player can see it. I might need entities to have their own separate visible grid. Discovered, so the feature this is used for is when you enter a map for the first time, the grid is entirely not discovered. So you don't even know what's there, it's just pitch black. But after you walk around a bit, you can see the rooms and you discover all the blocks, but when you walk away, that block is no longer visible, but you remember what's there. And that's the three tones on the map. Is visible is fully colored that you can see it. Not visible, but discovered means that you remember it and it's like grayed out. And not discovered at all is pitch black. But I actually have, if I go to the client, we can actually see that like these rooms are visible. These rooms are discovered but not visible. And these rooms down here, like this area, has not been discovered. But for debugging purposes, I made completely not discovered stuff have a little bit of visibility to it, just so I could debug the map better without having to go look at it all first. Overlay and UI sprites. These are two things I hadn't actually quite figured out what I want to do with them yet. The idea is a tile overlay would be like, if you want to like walk under an arch, you can have a tile overlay that is actually the arch graphics in each tile square, and as you go under it, maybe you like detect that event of you're walking into that area and the arch turns slightly transparent in the tile overlay layer. Or UI sprite, if you wanted to have like a target pop up on top of something, it you see that these are actually integers, just like the tile sprite is an integer. This uses that index sprite thing that you assign a tile sheet to a grid, and the only thing it has to store is the index of a tile, and it can display that. So that's what happens on every single square of the grid. And now the grid itself has a couple of hacks in here, like the TCOD map. TCOD is a great roguelike library, and basically what I'm doing is when I calculate visibility, I'm pulling data from my grid's not visible. Is it visible? transparency. I'm using the transparency grid and the player's position to build a TCOD map and then running those field of view algorithms on it. So that's how the player gets their visible lines back. How to build it, how to refresh the player's sight. Yeah, so not so bad. I didn't set up pathfinding yet. That will be another good thing to get by the end of the week. So basically, why do I need this component? I need to somehow make all of the data that's there available in Python without rewriting or without using the current API, which is kind of a huge mess. All right. What does that put? Where does that put me for priorities? Grids, other ones. There's no inventory yet. I have these key cards, which is kind of a cheat. They're basically global variables that get triggered by the Python scripts. Dialogue. I have more menus. Like maybe what I should actually do is let's close this guy and let's go back in time to show what I submitted to make a rogue face, which is actually has like kind of more features to it, like the walking event bug has not been introduced yet. The characters wander with respect to collision, and I have a lot more UI defined. So there's no collision with the other entities in this one. But I also have some test buttons, like I can make everybody move with their animation in one go. And they'll all wander, which is great fun. And also I have some example of what UI can look like with Python. It's of course incredibly ugly, but this will be pretty easy to shape up once I've got some more shortcuts built. So, where did I get that idea from? There's no inventory. I've got some animations. I've got the real-time stuff scooting back and forth. Okay, and what am I blathering on about in this block here? It's always the fun part about reading what you wrote a week ago. What did I even mean? Okay. Okay, sequence of events. That would be good. What I have here is kind of a complicated list of steps that I would like to implement for really the game to have physics, because presently there's a lot of checking in Python for is this spot blocked, can I move there, and then doing that, or just not checking at all and stuff goes on top of each other or goes into walls. I think for physics, I only really want to implement combat, where you have a kind of exchange of moves or attacks and throwing stuff. So those two are pretty closely related because I would consider like a fireball, a person that has been punched through the air, and an arrow or a spear in flight to all be quote unquote flying objects that also can have a combat effect. So the main things I want to implement to demo this is obviously bow and arrow or fireball, but also mega punch. So the idea behind that is just when you punch something, it will actually fly across the room in a straight line, either for a number of spaces until it slows down to a stop, or until it hits a wall. And to implement that, it would just need to basically change from a entity that's sitting there to a in-flight entity. And since roguelikes are generally turn-based, I need the physics for in-flight stuff to like run until it resolves in a single turn. So you launch an arrow, it's not going to move one tile. It's going to actually proceed along its trajectory until it hits a wall and bounces, or interacts with a creature. And when the arrow does that, then it can maybe like load your accuracy or check your luck and determine if that arrow is a hit or a crit or a miss. So in both of those cases, like if you're melee, then of course you need to go through this sequence of events to respect all your stats, determine the damage, proc your lucky events and all that. But for thrown stuff, you need to go through that same combat loop with the arrow itself that's come at you. So the arrow entity that hits someone, that arrow is going to have the damage and luck things associated with it. So the main thing behind that is that, like, I have a really simple turn system right now that basically you can see it in the 7-day roguelike one. It's that the player moves and then the computer moves. Then the player moves and the computer moves. In this case, when it's the computer's move, the flying object needs to finish its entire path, and then it will get to its destination. Okay, and ECS. So let's put that down. Priorities 1, remove bugs. 2, expose the classes better. And 3, this would be the ECS is the big one. But so what do I want to do for these? Combat and because really it's a simple tile-based game. The only physics you're going to have is can you walk there or not, and should this thing launch across the room. That's pretty good. But Obsidian really does not want to help me out with these numbered lists with bullets between. Alright, so the ECS is a hell of a thing. Super popular for games like roguelikes. The idea is that entities don't have different classes. You have the entity, and the entity has associated with it a ton of components. In this case, the only components I have mentioned are grid, inventory, and behavior, of which inventory and behavior are stubs that don't do anything. So inventory, essentially empty. I deleted the item class because I'm not sure if I really even want a separate item class. And behavior, which was meant to be a Python callable object. You could basically say, this is my object, my entity's behavior, and when events happen to it, call Python to get the right response, which is not the wrong idea, but it's not actually implemented anywhere else to use that object. Whoa, where'd I go? Okay. I had a pile of existing entities. Here's my text editor. Come on, text editor. Okay. So watching some other people's entity component systems, Scott Bylas had a really old talk. I think it's from like 2008, 2010. But I was able to get a list of all the components his system had. And a lot of them are stuff like specific to the story of his game. Like, oh, this is the thing to transition from cutscene to the next level, or vice versa. Also, some kind of like debug or script stuff. Let's see. I got a dev console item, all kinds of commands to do stuff. But probably more interesting, we have stuff like, emit fireballs, emit particles or something, have a glow to it, create sounds, generate stuff that explodes. You can respawn here. So basically this component can, in a really simple way, apply some capability or some scripts or some program response to an entity. So you can have an entity which can be as simple as like, as obvious as like a character, that would be an entity, but also something kind of subtle like an invisible spot on the ground that contains behavior. So when the player moves onto it, or any other entity, they can start a event that causes some action to occur. And you could add like the spell summon component. You could add that to any entity, and now when the right events occur, whether it's like an event of, it's my turn to pick a move in combat, what should I do? Check your own components, pick something to do. Well, now suddenly that NPC is able to summon other NPCs in the fight. And the components have their own data or requirements, but it's extremely broad on what the components can require for input data and perform in other behavior. And what you really want is to define small, lightweight components. I have some old ones here from the demo code this project grew out of. But the idea is your component contains the data, and then the final part of entity component system is you have systems, which is where the code actually runs. And for my game, that is not in the right spot right now. It's mostly all in the API class. So the API class has this entirely huge list of methods. It's just listing its own methods that it can access and explaining what they should be named and what the documentation should look like inside of Python. So let me actually refresh my own mind and go backwards through running this thing. So if we look in the scripts and go to test scene, this is the script that runs when you start the game and enter that scene. Python doesn't require separate files, so I have the entity class right up top. It defines all these data things. Yeah, it's able to move, it's able to start an animation. So this would be like the meat and potatoes of anything animating, is that it calls the API and says create an animation. We've got a time, we've got to tell it what is that? Menu item or grid object is being animated. But this is, I would call this an Annie pattern right here, is that we have to give it a grid, which is, it's actually a string. It's a lookup key in the dictionary. And then we have to give it animation type and give an integer the number of that item. This is all completely wrong. What this should look like instead would be something like, let's see, duration in seconds. That looks good. And what is it animating? Okay, so we got a Python callback, handy. That's how it knows. It counts how many animations are going on. It adds up when it creates them, subtracts down when they're done. When it hits 0, it's the player's turn again. You gotta wait for the animations to complete for the next cycle of the turn to be started. But this would be a lot better if it was something like, I mean, really, I'm editing the wrong spot here. Like this won't work because this isn't how the thing, the AI or API works right now. It should be something like create animation 0.15 integer index for menu or grid objects, none for a grid or menu. So that should be recalled. Oh, in the frames, where is that at? This is some kind of mathematical hack that only works on my current tile sheet, but because really all that stuff should be included. I will want something that says attack frames or something, so it can just have a list of frames, have a duration, and automatically figure out what it should apply to. The trick would be exposing it on a method on the object, so C++ doesn't have to look up so much stuff. It would be kind of included in the API connection there. But I'm getting on a tangent, aren't I? That is what I would like it to look like, though. So we've got entities, components, needs work, systems. This code needs to live somewhere, and it needs to live someplace I can actually find it. Okie dokie. Oh, actually, probably a lot of the meat and potatoes of the code is inside the Python scene class. A lot of this has been gutted. I was trying to clean up last week to get ready for this. Like here's WASD and some other keys right near that, as well as the numpad keys being registered events. Register events like move the player to this position. And what those end up doing is, where's the key behavior? Left click, right click, zoom, do action. There's the movement actions. And it's like a call to the API from C++. Python should just be able to do that directly, which it does, but it doesn't have the same, like let me go to the definition of up left. Right, so this has an action code register action key plus Q. Okay, so when it actually performs the action, action once is the macro that has it. So action once means that it does it a single time when the key press starts. Like when you press Q, you get an event that the letter Q was pressed on your keyboard. When you release it, you get another event, same key code, different event type. That's a release instead of a press. And action once only responds to something at the start event. Other stuff, the Python version is responding in both cases. So that's a good note. Components, systems. And I think I got some other stuff here about how to efficiently implement components in basically text files that define them is a popular thing to do, so you don't have to recompile code just to change the components. Loading those components and then efficiently operating on them in C++ would be good, because really the idea is to have a lot of performance even when there's hundreds or thousands of entities doing thousands of different components. But I will put all of that off until the third sprint. So let's focus on this stuff. So I don't know that I can get all of that in, what did I say? 16 to potentially 21 hours of development. So let's get a little more refined. Wow. Firefox is not enjoying running these streams. Oh, I can just start it back up. Try again. Okay, so for the next 3 streams, I would like to let's try to pick. Let's switch. I can probably do metrics on the number of API calls I have. So this should be a good stand-in for, let me count them. I'll grab these here. I haven't called it jank in the file I defined it in. So let's have a look at this guy. So these are my methods. Let's count them and maybe give them a category or 3. The comments are still in the code, so let's just try to get the definitions. and remove some of these variables. Input mode, turn number, not relevant. Bool cam follow. Okay, so let's go with 1, 2, 3, 4, 5. Oh, this is good. So where I have create, list, and mod, those three if I expose the menu class, then these three will not be a problem anymore. This is caption, texture, sprite. How should I split these? Entity, list entities, grid, list, grid, mod, grid. So this should be and this is good because I think once I figure out how to do it for the menu class or the grid class, I can do the other one really quickly. But these guys would be, let's see, that would be the button class. So when I have create texture, list textures, that would be one API, like I have to double check, but I think this might be something on the game engine itself. So the game engine object holds all the global textures, which is like your tile maps, all those sprites, all the sound effects, all the music that's held inside the game engine and can be used across any scene. So textures and sprites might be up to 3 there. List captions, list buttons. This should also be, I would say, so there's a UI menu class, which is any box you see on the screen. And those boxes can contain buttons, they can contain captions, and they can contain sprites. Sprites have to refer to a texture, so I'm actually gonna move this here. That should be 2, because you don't want to create textures and list textures. I might need to expose the texture class, but also the game engine where they're being stored needs to, like, you don't want to create a texture class yourself. It's really something that you don't want to hold on to it in Python memory on your own. It's only any good to you if the game engine is holding that texture. So might want to expose some kind of constructor for a texture in Python so you can load file names from a script, but they still need to reside in the game engine for the memory to be in the right spot. So what else we got? Oh, some of these are already commented out. Yes, some of these are commented out. Whoops, why is that the next window? Okay. So what else we got? Animations. Register, Py actions. I think this is all game engine stuff. Volume, yeah. 1, 2, 3, 4, 5, 6, 7. Turn management is not actually really well defined, so I need to make some time to figure out what I want to do with that. It's a little too generic right now in how the code actually works. I mean, the opposite of generic. It's kind of a kludge. Active grid. What does this actually do? Let me go look at that. Let's have a look at active grid. Okay, so active grid, it's going to give a string, whatever the API's active grid string is. Set active grid is going to set this string to whatever text Python passed it. So it's really only setting the active grid to a string. And where is active grid used? It's used to find entities for running the computer's turn. And it's used to animate the camera's position as the player moves around. Is it used in Python scene? The mcrfpy_API active grid, not used. Okay, so it's really only used for those two features. Let me make a note. Active grid and set active grid for computer turn and camera following. So if I'm not going to tackle those two features, the turn cycle and the camera features, I need to either make sure those get left alone or put them into same defaults when I take them away. And what else we got for, oh, man, camera froze with me in a real goofy position, didn't it? Yeah, new cameras in the mail. All right, so what was I going on about? Input mode. What the heck does that do? It's a string. Input mode, player turn, and computer turn wait. And was there another one? Computer turn wait means, okay, you can also set it to whatever you want. Input mode, compare. So no input accepted while computer's moving. That's how it consumes and throws away your keyboard input when you're wow, I watched this thing turn off now. Let's try the other format, see if it likes that. So input mode gets set to a string and used to check if the player is allowed to move yet. So let's do any and all of that. Input mode, turn number. Okay, so this would be used for which is not really how I want it to work. It's a little too specific to the demonstration rather than something you'd actually be able to modify and control for any other game's purpose. Okay, and cam follow. Okay, so I can pick some things to reduce my kludge API calls by the most by implementing certain stuff first. And it looks like I really need to expose the C++ classes for everything UI through Python interface, which I will start now. See if I can get something to compile, and I'll compare my notes on exposing a C++ class. But let me just put that as my mission statement for what I need. 2. Yeah. Well, that's 1. Priorities 2, metrics 2. So goal statement. For sprint 1, I am going to, and that's during the work week, Monday, Wednesday, Friday streams. Let's expose UI, menu, button, caption, and sprite. What else can I do to, oh, maybe do some debug stuff too, but we got to find the carrot and find the stick. So I think I'm gonna have fun working on these API classes. So instead I need to space it out with the stuff that's going to be a huge pain, which is going to be build on Windows and chasing down the camera mode bug. Figure out what event I need to set that up. It might not be that bad. So let's take all bugs, and maybe I'll have to move some of them to next week. I should put a okay. All right, is there anything else I can do in 6 hours? Maybe not. So let's call that my goal. So let me kind of do the refinement for sprint 2.3, and this will just be like a conceptual. Honestly, I need more of a plan for sprint 2, but I'll get that towards the end of the week when I can actually see what's done. Again, let's keep this kind of loosey-goosey. See if my stream imploded. So let's say for weekend 2. What else can I get out of my priorities and goals here? Maybe like expose some more classes and tinker at ECS. So let's say grid class. That's going to be a big one. Entity. Animation. That's all going to be important, meaty stuff. And then sprint 3 will be I mean, ECS is the big picture of it. And if I have time, something like more tech demo. I I have really good friends at a Discord server. I didn't even call that. Let me go over to my Discord and look at it. The Very Epic Tavern, of course. And the guys there, Shade, Octoshrimpy, my absolute favorites. Huge pile of really adorable pixel art. And I think using more pixel art, you know, really I'm making this engine to showcase those great pieces of art. I could not draw that stuff myself. Like, I even have access to those tile sets, and I'm still using colored squares in my map because I'm so artistically deficient. But I think that's it for planning. Let me call that good. That's close enough. The customer approves. That's me. I'm also the customer. So let's take a crack at exposing a class through Python in C++. Plan, go away. Okay, so what I will do is pull up in terminal I have here, oh, I put it in xplat. Okay, so this is a older repo that I was using. I don't think I even shared this, but if I run it, nope, I said a bad word. Basically, that's what happens when you code drunk. This thing, well, it's not even really that much to look at. C++ executes a Python file. It also exposes some classes and functions to the Python API, so the Python script can actually call functions that were defined in C++. So let's close that. I'm just not going to be able to see if the stream is working, aren't I? It's a combined proof of concept is what I called it. Oh, it's in source. That's the only file. Let me just yeah, take that out. Let's not use bad words on the stream if I can help it. Okay, so here's the point class. And this is a super simple class in C++. We have two floating point numbers, x and y, and we have a method, magnitude, that gives you the length of that vector, or the distance between the origin and that point. And bam, easy peasy, right? So to make that available in Python, we have to define a new method and a init method. So this, honestly, I don't even really know the difference between new and init in Python itself. That's a bad thing to admit. But in this case, like, we can see when it's initialized, it allocates the memory for a point. And it sets those values to their initialization. So there's no initializer in C++ that really does anything. So you just you get a pointer to it, and then you set the values yourself. If I wanted to, I could define a C++ initializer and call it here on the pointer to the object, but it just needs to be able to be instantiated, at least a pointer to it, with no behavior, no arguments, because TP-alloc is going to do that call. Then we have a init. What does this thing do? We have some example code that I put in and don't quite follow. We have 2 float arguments. I think that means they're optional. X and Y. So that should allow us to take the values for X and Y and assign those. So when I say points in Python, I can provide the values for X and Y. Those will get loaded into the C++ type. Finally, every method that needs to be exposed, I actually can use self as a pointer to the type, the C++ instance, and just run the methods and plug them into Python data types. And this is how you get the big performance gains, because once I expose this method, Python can call it, but it's all being executed in C++. There's some caveats that, you know, the interpreter has to still be set up and all that, but you still get a huge performance gain over just writing this stuff all in Python. Finally, we have to define all the methods that are being exposed. This is also a chance to give doc strings in Python. And what is this? A struct of the member values. And finally define a Python type object struct, which assigns it to a module, how much memory it needs. I think for my module here, I have point is the name of the module, and that's a separate module that's in there. So we have our point module, and with all that, I should be able to say build run. So we have our REPL. I should be able to say input point. So point is going to be that module we have, and point.points is going to be the class that I basically the Python class is just a definition to interact with the C++ class. So if I say p equals point.point 10, 12, I can see that we have a points object that needs a repr definition, p.x, p.y. There's those floats put in there, and p.magnitude is going to give that a value right back. So I should be able to do some other stuff like p.x equals 3, p.y equals 4, p.magnitude 5.0. So it's working pretty well. This is exactly how I would want to use it, is just put in the definitions for a class, put that into Python, and then mess with its memory and all that directly from a script. So get out of the REPL, close the demo, and let's just pull that all out. Let me zoom out a bit so I can copy paste a little bit better. Okay, so I think I have some yeah, that's what the other module exposes. So a little bit of a mess, but that's how playgrounds work, right? So let's take this class, new init. I'll get magnitude in a second. And what am I going to do? I'm going to paste it in a blank text editor. So what is that? New and init. Let's get magnitude, PyPoint methods, PyPoint members, PyPoint type. Oh, I also have to get the module. Okay, magnitude. Because now what I'm doing is, like I managed to get this far as a demo, but now I need to turn it into a recipe because I'm going to do this a lot of times. And I don't know if it's going to be tedious or just easy, but this is the main idea, is to go through, where's my code? Here's grid definition. Now, here's a question. Should I put all of this in the API class or in each class's individual file? Let me just try to get something to compile. Then I'll wrap it up because it is getting close to 10 p.m. on a work night. But let's take something like a UI menu. Oh, that's going to be a complicated one. It takes a SFML object and it's a initiator. Oh, I can short circuit it, use a default one. I think what I could do is, yeah, I think MCRF PAPI does have a font. Game get font. That's what I'll use. Because I only use one font in my engine right now. That's maybe a shortcoming, maybe something I need to address. I'll add it to the backlog. That'll make me feel better about it. Now, I should probably put that on screen, shouldn't I? That's it's not difficult to do. It's just, you know, requires plumbing everything and isn't interesting work. So it'll probably be a while till I get around to that. So let's maybe go with the Python scene. I don't know. It's let's see where it's already added in the API. Okay, so we have a method structs, and that has all of the MCRFPY, which is mic rogueface Python methods. So great. This would be a fine place to do a hacky compilation test. So got my notes up. Just drag those over. So I already have a class UI menu. Let me pull this up over here. So that would be so what am I going to call this? Py UI menu new. I probably don't have to type this, but I could copy and paste a little. He says as he continues to type it. Keywords. And this is going to say UI menu. Does it even have a constructor? Where is that? All public members because I'm a savage. The default constructor is actually not defined. We have another one. Yeah, it requires a font. So I don't know how C++ is going to react to that. Let's find out. So that will be UI menu. Comma 0. And if, because that, yeah, that's going to need some kind of initialization. And I don't know how to do that. Let's Google it really quick. Oh, I'm going to have to turn my browser back on. See if my stream caught fire. Still running? Yep. Not gonna look at that. Keeps crashing my browser. Let's go to. We're Googling it. Okay. TP-alloc with args for with constructor args. Let's see. And let me just look for constructor. Include a PyObject field. Maybe I actually have to read. What does it say? Let me just add that. And I know I should be using Boost Python. I just don't want to. I'm really trying to keep this with the stock API. And I know that's kind of lame, but I'm learning more that way. So I'm sticking with that decision. Okay, so placement new. That's all right. Doesn't really answer my question. Let's just try to go live. All right, so this looks better to me. Okay. And what goes on a UI menu? Needs a font. Has some vectors. Yeah, box shape. should be fine for now. There's new. And what should init do? I don't even know that I need any args for this. Should probably put in as no args. I'll just put it in as no args. It's the same same as magnitude. So what does UI menu have for methods? Render. And I think the way to do that would be doesn't really need call render from Python. That's how it draws. Let's go with add caption. And that looks like magnitude. Oh, that has by the way, that should be UI menu self. Got to come back to that. Next, need to define and those would be captioned button sprites. And I think this is going to be bad because that's way more complicated than the demo. But and type def. Okay, how's that look? More or less correct. And the module def, where's the MCRFPY module def? head init, name, no doc, no size. Oh, I need to add the methods to the same method def. Member def. Where's this defined? Okay, let's let the compiler tell me what I did wrong. Oh boy. So if I run it, doesn't crash. Let's go to the REPL. I don't think I can do that with, it seems to work. So let's say menu. So it was, we have members, UI menu type, I don't know how to add it to this existing module. What did I do to get this guy? No. So let's find point. Oh, so we have member def, point type, PyPoint module. So let's find PyPoint type. Okay, so this does PyModule add objects, PyPoint type. And that's inside of the, one of these module init functions. So this needs to go to my blueprint. So let's find PyModule create mcrfpy module, and now let's say we're going to increase the reference type to now we're going to attempt to add it, and if it doesn't work, by the way, we need to say PyObject m equals that module, and if it didn't work, we can't continue. Finally, after we do that, we should say, what is this if statement? PyModule add object. The module's M. Okay, I think that means as long as we don't get a error code, whoops, still thinking in Vim, save that, and I hope I didn't just get a successful build because I didn't save the file. Whoops. Let's see how many crimes I've committed against syntax. Yeah, there it is. Oh, there's no methods. Members, methods. It should look like this, but so now that it's there, I'm gonna add the backlog to fix my compile script too. Whoops, that would be a missing semicolon. Got me. Probably should take out the different test point. And caption button sprites. Yeah. No idea. Wait. Huh. Don't know how these labels are in scope. Never used offset of, so. Oh yeah, overtime. It's time to go to bed. That's problematic. List is not actually known. So I'll have to find a list type Does this have any normal members? Not really. Oops. Visible. I think I might have a problem with C++ classes having more complex data layout, especially with standard vectors in there, compared to C structs that just have strictly calculable offsets. And what does this say? Yeah, this is going to require some research. Alright, I got a general idea of what I'm up against. I got a general idea of what I'm supposed to be doing throughout the week. I got a general idea that it's going to give me some issues, but that's what we're here for. So, that is the end of me goofing off tonight. And see you Monday night. Everything going well. Bye-bye.